micron size. However, when we use the biomass, so it actually disintegrates into the actual form where actually we have done the pelletization. So it actually elongates afterwards, and some kind of layers actually between the milling surface and the mills actually they create, and afterwards it decreases the milling surface, and the load and the current will shoot up. So based on the pneumatic conditions and the studies also, we have confirmed that 1 to 3 mm of particle size of biomass is actually suitable for the co-milling operation. If we see the proximate analysis of the coal and the biomass and we compare it, then we can see that the GCV is already almost equal of both of the fuels, slightly higher in terms of biomass. Both have taken in the air-dried conditions, so moisture is not taken into the consideration here. So one has to keep the moisture level at the prescribed limits. However, in the volatile matter, if we see that 67.29% of biomass at that time we have tested, as compared to the 22.19% in the coal, so that is actually having a huge impact on the combustion side and the mill side also. So it will cover in the next slides. If we see the ultimate analysis, so here we can see that nitrogen and sulfur contents as compared to the coal, biomass is having very less. And that is why it was predicted that SOx and NOx pollution would be less. And that was also validated after the actual trial run. If we consider the H by C ratio, so for the coal is 0.08. However, for the biomass is 0.12. That is a higher side. And literature, what suggests about the H by C ratio is that if it is higher, then flame speed would be higher, it will get combusted quickly, and the radiative heat transfer would be lower. And the heat release pattern overall inside the boiler would actually change as compared to the coal combustion. So we actually taken care of that parameter as well. This is one of the lab equipments called STA, simultaneous thermal analyzer. Here actually we do we actually give the heated ramp rate of around 10 degrees centigrade up to 700 or 800 degrees, 700 to 1000 degrees centigrade actually we get combusted. We actually combust the biomass and the coal. Then we get this curve for the devolatilization rate. Here if we see that green one is the coal curve, and this yellow kind of curve is the biomass curve. And here we can see that it's not working. Actually, the starting part, which is a linear curve, that is actually the part where moisture gets actually released, and afterward the devolatilization rate starts and the combustion just start afterwards. And this is the slope where actually we see the combustion at what temperature we are having the complete combustion. And afterwards we are also getting the straight lines where actually the only ash part is remaining. So residual mass, that is ash, is only remaining, and we can see that residual mass of the coal is around 36 to 38%, and for the biomass it is around 14 to 15%. So in that terms, for the devolatilization rate of the coal is around 340 degrees centigrade. However, for the biomass, non-torrefied biomass, it is around 190 degrees centigrade. So in that way, one has to keep the mill inlet temperature to reduce up to 190 or 185 degrees centigrade to avoid the mill hazards, including mill fire. If we see the ash fusion temperature, so ash fusion temperature is comparatively low in biomass as compared to the coal, and it is actually giving the direct impact on the slagging, agglomerations, and the clinkering part. Alkali and chlorine content, as I already mentioned, that both are at higher order in terms of as compared to the coal. So because of alkali actually falling in agglomerations are the normal processes where one has to keep the things at finger point, so that one has to take care of this. And for the chlorine-fluorine content, that is responsible for the hot temperature corrosion. That is still a long-term phenomena, but one has to monitor it. This is a drop tube reactor facility, which is actually a miniature form of the PC-fired boilers. And it is having a main furnace of around 15 degrees centigrade. This is the facility developed by NTPC Netra in collaboration with CPRI Bangalore. And this is India's first and only reactor where actually we are getting the 1500 degree centigrade temperature where we can do the actual testing before the actual trial runs. So in that equipment, so coal feeder and the primary air is actually fed from the top, and the secondary air is coming from the right side, which is heated already. And this gets combusted into the main furnace, and the residence time and the kinetics, we actually evaluate it. And after we have the two collection probes, one is vertical probe and one is horizontal probe. So in the vertical probe, actually, we can have the combusted combusted ash part. Actually, it is having a nitrogen jacketing and the water-cooled jackets. So whenever it drops to the probe, it actually stops the combustion. And afterwards, we can collect through the fine filters. However, for the different, another horizontal probe, where actually one collects the biomass ash, and one can see that how its nature behaves. So I'm covering that part only here. That rotating coupon is there, where actually we collect actually the biomass ash, and we have seen that it is a very loose nature as compared to the coal, and actually it behaves very similarly. And it was envisaged that it can be easily removed by the soot blowing operations. So till 10% and more percentage we have done that. However, we have given the 10% co-firing recommendation based on the all factors. This is the schematic of the biomass actually handling and conveying side. So Dadri executives will present in details. I'm not going into detail of this. These are some of the success stories. Around 25 plants are listed here. Many more plants have started or at least started the tendering or the other parts for starting the biomass co-firing in India. So these are the success story after the National Samarth Mission initiatives. This is the actually part where I have covered the non-torrefied biomass for the utilization in PC-fired boilers. However, we understand that 65% of energy demand is covered by the thermal plants only, and we have to take the initiatives where we can make the thermal power plants green, because they are going to be operated in multiple decades, because we do have other challenges such as availability of renewable energy and the other parts. So for the higher order co-firing, the alternative approach is the biomass torrefication. So basic of the torrefication is that we do the combustion, heating or the combustion of the biomass non-torrefied in an anaerobic condition, which is lacking of air. And almost 250 to 300 degrees centigrade temperature is there. Holding time is around half an hour to 1 hour based on the design specification as per the vendors. And it actually improves the quality of the biomass significantly, which is more suitable to the thermal power plants. It improves the GCV by around 20%, and it makes the biomass in a very energy dense form, and it has characteristics of physical and chemical properties like coal, which is high calorific value, excellent grindability, high bulk density, hydrophobic nature, and no biological activities as compared to the non-torrefied biomass. So this technology is proven and cost competitive technology. Torrefication is also a need of our, and the entire biomass sector is actually geared up with these initiatives also. So if we go towards the R&D part of how we have arrived that torrefied biomass can also be fired in the higher order. So this is the rice straw samples, and other samples we have also tested. However, I'm presenting here for the rice straw samples only. So we have prepared the samples of around 10 to 100% different blends along with the coal. And afterwards, if we see the proximate analysis, so we have taken the biomass and the coal sample as dried basis. So I'm not considering the moisture level here. However, we see that ash content is gradually decreasing. and the volatile matter is increasing after RS3, that is 30% of blend. So here actually we can see that till 30% of torrefied biomass pellets can also be easily fired in terms of proximate analysis. However, other analyses are also important in that terms. If we see the ultimate analysis, so again sulfur and nitrogen contents are low in this area. So again the same was envisaged that SOx, NOx pollution would also be lowered down, and sulfur content is less in rice straw already. So, and RST shows almost linear change in properties with blending. If we see the ST analysis where we have evaluated and ascertained about the devolatilization rate for the different biomass blends. So, as we know that coal VM release around 300 or more temperature, but torrefied rice straw that biomass into the consideration, which actually releases the volatile matter in around 220 degrees centigrade. So, whereas earlier condition for the non-torrefied, we do have the limitation on the mill inlet temperature, and the mill hazards and mill fire were the probable expectations or the problem hazards. So here actually we can have the temperature which we take into the case of the coal. So there will be, there actually we can use the torrefied biomass in a higher order, in a higher capacity utilization factor also, along with the same parameters of the mill inlet temperature, what we actually use in the coal fired mills. So this is the ash fusion temperature analysis, where actually we can see that till RST3, actually IDT is almost similar to the coal. So here also we are safe in terms of slagging and the other behaviors and the clinkering and agglomeration point of view. So here till 30% we are also comfortable with that. And for the clinkering and slagging process and behavior of the coal and biomass, so we can see with this graph, actually we have conducted the slagging analysis through different analytical and simulation methods, where we can see that from RS2 to, between the RS2 to RS3 actually, that means 20 to 30% actually, slagging zone is very moderate or very low. However, the possible slagging zone is afterwards. So here also we do have the limitation that we should use up to the 20-25%, and same goes to the alkali content in the biomass as well. For the chlorine-fluorine content, which causes actually high temperature corrosion. So here also till 30% of the blend actually we are safe in terms of safe co-firing. However, afterwards actually the possible corrosion zones would increase. If I summarize the previous slides in terms of torrefied biomass analysis and the R&D part, so we are already aware that almost 20, 25, 30% biomass co-firing is possible in terms of torrefied biomass, and that is why we have given the safe limit of around 20% torrefied biomass co-firing recommendation, and in coming future, our engineering team, our other site team will start the co-firing process. We are at very high, advanced level of that process also. So we are going to do that in a near future. Thank you so much. Thank you so much from my side and for the patient hearing. If any questions from the audience side, please feel free to ask. Yes, sir, please. Yes, we have actually conducting, because right now, along with Samarth mission, we are working on different 4 to 5 R&D projects, where actually we have characterized and along with engineering team also, we are working on various other fuels like mustard, bamboos, and subabul, eucalyptus, and poplar. So those are the fuels actually we are working as per the requirements and as per the requirements from the National Biomass Mission or the other departments or the other stakeholders from biomass sector. Bagasse, yes, Bagasse is also one of the area where we are working on that.
Sir, see, as you have pointed out all the various factors के bagasse को the biomass how suitable is compared to coal. यही हम अपने clients को जब समझाने जाते हैं ना तो वो बोलते हैं कि emission तो बराबर है आपको हम क्यों briquettes और pellets को replace करें coal के साथ में. तो सर हम समझा नहीं पाते हम ये चाहते हैं कि सर आप इस तरह की reports को publicize करें NTPC के प्लेटफॉर्म पे हम उसको दिखाएं कि इस तरह की ये रिपोर्ट्स अवेलेबल हैं तो आपसे जैसे रिक्वेस्ट है कि इसका या तो कोई बुकलेट फॉर्मेट में या रिपोर्ट फॉर्मेट में इसको पब्लिसाइज करें सर.
Now your point is well noted, but this link is already live and YouTube also you got the presentation and everything, presentation in a detailed manner. And apart from that, your first question I would like to reply, because coal, as I already mentioned in previous slides, that coal is a non-RE fuel and the biomass is a carbon neutral fuel, where actually whatever the carbon dioxide we releases into the atmosphere after the ESP and the other procedures, where actually the particulate matters and the different parts are being controlled, so it gets actually absorbed by the next stop of cycle as well. That is why it makes it a carbon neutral fuel.
सर PM emission PM 2.5 and PM 10 का कोई डाटा आपके पास है क्या?
Sir, probably the other team would show you, but right now I don't have.
Okay.
Sure. So
just wanted to know if you can share your findings about the bamboo.
So it will take time because we are working on the National Biomass R&D project, and obviously our Samarth mission would publish these results in future.
Is there any restriction on the biomass which is possible to use as animal feed? When, as I understand that the biomass which can be used as animal feed, for example, this wheat straw and the rice straw, which is equally usable for animal feed. Is there any restriction from the government that these feeds cannot be used for producing pellets or other?
So this detailed technical specification along with guidelines actually are released by the MOP and the CEA as well.
I'm not asking the technicals, I'm asking for the policies, this thing. Are you aware of any policy guidelines which says the biomass which can be used for as animal feed cannot be used for making pellets?
Sir, till date actually we haven't worked on that part, and this is a policy point because I'm mostly covering the R&D part. So if any question within the slides, then please, you're welcome.
My question is, we are saying this biomass is a this carbon neutral fuel. Is there any study which depict that this much is the emissions during burning of the biomass through most efficient process in our thermal power plants, and this much is the carbon dioxide our crops are consuming?
No, we are not saying that this is the most efficient technology. We are saying that since we do have the problem of the open field burning and the other climate issues, thermal power plants are actually being regulated and through the RE as well. So this is a one kind of innovation you can say where we can utilize our thermal power plants, because that has a very huge capacity for the energy consumption demand. So that is one of the ways, and in fact other areas like CCUS and the other enabling technologies are also coming up, and some of the technologies has already been proven. So along with all the technologies actually one can ascertain a best customized way. There is no any best way or something the most efficient way, because as per the situation, as per the customization, you have to switch the technologies as well.
Agreed. My point was carbon neutral fuel. This biomass is a carbon neutral fuel. Is there any study which can say that this much is the emissions during the process of burning of pellets from biomass, and this is the consumption of carbon dioxide during growing of the crops? Any comparison?
Right now I don't have.
Can we say, I mean, in another way I should ask, can we say that this biomass is 100% carbon neutral fuel or carbon negative or carbon positive? I mean, is there any study? This is my question.
I think this studies has been carried out by our engineering team also, because one day event actually, if you get the chance, sometimes you attend. So my colleague Mr. Ashwani or Pankaj sir, they actually give the presentation on that. So actually they do have some calculations, but apart from that, probably over the open source actually you can find some kind of studies. But right now I don't have.
Thank you.
Hello.
Thank you so much.
Excuse me. Hello.
Sir, can we have the rest of the questions later, sir, after the next presentation also? Thank you very much indeed. We'll have time after both the presentations are over. Thank you. श्री अजय सूत्राकर जी का हार्दिक धन्यवाद करते हुए अब अगली प्रस्तुति के लिए आमंत्रित करना चाहेंगे श्री विवेक सिंघल जी को। उनकी प्रस्तुति का विषय है बायोमास co-firing experiences and combustion practices in NTPC. And ladies and gentlemen, Shri Vivek Singhal has completed engineering from IIT Banaras, Hindu University in 2009. After working for 10 years in NTPC, Rihand, he has joined NTPC Dadri, and he's having 13 years of operation experience in 500 megawatt thermal power plant. And let's put our hands together to welcome him for his presentation.
Thank you, ma'am. Very good morning to everyone. Myself, Vivek Singhal, along with my colleague, Mr. Bharat Barun. He is Senior Manager in Fuel Handling Department. So, topic of our presentation is the biomass co-firing experience of NTPC Dadri and the combustion practices we are following in NTPC. So, presentation highlights will be that first we would discuss about what was the need of the biomass co-firing and what was the experience of NTPC Dadri, as NTPC Dadri was the first pilot project for biomass co-firing. And based on our experience, we did some modifications in our power plants, thermal power plants, to suit the co-firing of the biomass. So we would go into the details of the also. And finally, the environmental benefits of the biomass co-firing. As we all know, that heavy smog is a very common phenomenon in northern India, especially during the winter season. So one of the main reasons of the smog, as we all know, is the agriculture residue burning. So what is the solution? We can burn this agriculture residue. If we are burning this agriculture residue in the farm, then we are creating the pollution. But if we burn this agriculture residue in the thermal power plant, then because thermal power plants are equipped with the effective dust control mechanism, we have ESPs. So there would be no pollution. But how do we burn it? First, we would convert this agriculture residue into the biomass pellets, and this biomass pellets will be sent to the thermal power plant for the burning. Because biomass pellet firing was never done in India, so for the study purpose, NTPC Dadri was identified as the pilot project for the first time, for the first time of co-firing. Now, Mr. Bharat Barun will take over.
Thank you, Vivek, sir, and good morning to all. So in 2017, when NTPC Dadri was identified as the first pilot project, a team was formulated, which comprised of people from CCOs, Netra, that is our research wing, and people from site, and various brainstorming sessions were done. They came up with the specifications of the pellet, the operational procedure for safety operation. At NTPC Dadri, we have 4 units of 210 megawatt and 2 units of 500 megawatts. So at first, it was decided that that 5% blended coal with biomass would be fed in 1 mill of unit 4. Gradually, the blending percentage was increased to 7.5%, and later to 10.5% of blending was done to only 1 mill of unit 4. Later, when the confidence were gained and positive results were seen, then the blended coal with biomass was fed to all the running mills. So here is the technical specification of biomass that we are receiving at NTPC Dadri. So here we can see the different parameters like material, shape, diameter. Here we can notice that the GCV that we are receiving is at par with the GCV of coal, that is 3800 kilocalorie per kg. we have a provision for penalizing for the biomass that with low GCV, that is below 2800, and we incentivize the biomass samples with higher GCVs. So the ash content is also very low. Next slide, please. So when we receive any truck of biomass, then after weighment, it is placed at the platform that we have erected at our site. The samples are taken very safely and taken to the chemistry labs. After first of all, the moisture is checked. If the moisture content is more than 14%, then we outrightly reject the sample. After checking the moisture, the sizing is done, and if we get the clearance from the chemistry department for the moisture and sizing, we unload the biomass truck at the site. So the proximity analysis and ultimate analysis was done. Here we can see when we use 100% coal, then the ash content is too high in comparison to 100% biomass firing. But the volatile matter increases as we increase the biomass. The next slide, please. The sulfur content in biomass is low, so when we increase the blending of biomass in coal, we reduces the SOx emission, and the ash content also reduces, as was discussed by the previous presentation. So here we can see in this in combustion analysis, we noticed that the biomass devolatilization starts at 200 degrees centigrade in case of biomass, while in coal it starts at 300 degrees centigrade. So when blending is done, we cannot increase the mill inlet temperature beyond 200 degrees centigrade, because in that case devolatilization will start for biomass. So we restrict the mill inlet temperature below 200 degrees centigrade. So as it is previously discussed that in 2017 we did biomass co-firing test at Dadri in 3 phases. In first we did 5% blending in one mill. Later it was increased gradually to 10% blending to all the running mills. And based on our experiences, we developed the storage facilities for biomass, and we started feeding to all the running mills of 210 units, that is stage 1 units. On 4th December 2018, it was a day of pride for NTPC Dadri, because on that day commercial co-firing of biomass was started. Later, after gaining experience, we started co-firing in our 500 megawatt units of stage 2. That was the date 16 December 2020. So here is the emergency hopper. This picture depicts the emergency hopper. So the first 2 trucks that came to NTPC Dadri was manually unloaded. Usually in starting days, biomass used to come in sacks. So it was unloaded at the yard itself, and blending was done in the yard. So this blended coal was fed through payloaders in the emergency hopper. Later, the consignments were fed directly to the emergency hopper, and the blending was done at the conveyor. So this hopper is comprised of the rack pinion arrangement, and we, through our experience, have set the opening of the gate to 5% blending of biomass. So we have a facility for a separate facility for truck tippler. Since because of the biomass policy, we have to feed 5% of biomass daily, which amounts to be a very large quantity of biomass, and this cannot be done manually. So this truck tippler tipples the complete truck in one go, and we can feed the biomass through payloader. This is the future scheme which will be implemented pan-NTPC. Here we will erect a separate new truck tippler, and using this bulk receiving unit, the bucket elevator will lift the biomass to the silos, which will be of 750 tons each. 2 silos will be erected, and through these silos, this biomass will be available 24/7 to be fed to our bunkers. This picture is of initial days when I already told that in initial days the biomass used to come in sacks and it was unloaded manually, and we used payloader to feed it to the emergency hoppers. This is another. This is our emergency hopper. Okay, we have our emergency hopper in stage 1 yards. So the biomass is fed to stage 1 and stage 2 bunkers through these emergency hoppers only. So we have an arrangement of interchangeable conveyors. We can take coal or biomass to stage 1 from stage 2 and vice versa. The first picture is of pure biomass being transported from conveyor, and this second one below the first one, this is the blended coal. So here's a picture how we do the blending. So when we have a rack of coal at our wagon tippler or track hopper, then pure coal is transported to transfer point, and we feed biomass through these emergency hopper, and biomass travels to the transfer point, and blending is done at the transfer point. Then the blended coal is fed to the bunkers. But when we do not have any rack, or we do not have to reclaim this coal from track hopper, then we reclaim coal from the stacker reclaimer, through stacker reclaimer from our yards, and the biomass is fed to the emergency hopper. The blending is done right at the conveyor itself, and this blended coal is transferred to the transfer point and thus to the biomass, to the coal bunkers. When we have to feed to the stage 2 bunkers, then the coal is reclaimed from the stage 2 reclaimer, and this coal travels to the transfer point, and we take biomass at the emergency hopper. This is for stage 2 bunker feeding. So further slides will be taken care of by Vivek sir. Thank you.
Thank you, Bharat. This is the picture of the pulverizer system which we use in a power plant. So this is the bunker. We can see this is a bunker where the fuel is fed into the bunker and kept in storage condition. Below bunker is the feeder where the controlled feeding is done to the pulverizer. And below it is the pulverizer where the pulverization of the fuel is done. And separate two lines which are coming, white color lines, these are the air lines. Above is the hot air line where the hot air comes, and below is the cold air line. The mixture of this hot air and cold air goes to the pulverizer, and this high temperature and high pressure air carries this pulverized fuel to the furnace by using all 4 pipes. Whenever we are feeding the 100% coal, then we have no issue because the mill inlet temperature is normally 300 degrees centigrade. But when we are firing the biomass, then in that case we need to change the biomass mode, because as already explained by Mr. Ajay sir also, that volatile matter content in the biomass is very high. So we need to take the precaution in the from the temperature side. So for that purpose, the separate biomass mode facility has been provided by the control and instrumentation area. So biomass mode will be kept in on condition. Apart from that, because inlet temperature is very important in case of the biomass co-firing, so separate additional temperature point has also been provided for the biomass co-firing. Also, the control philosophy, mill control philosophy, normally in 100% coal firing, mill temperature control philosophy is based on the mill outlet temperature, because mill outlet temperature is not important to us because it is maintained around 300 degrees centigrade. So we maintain outlet temperature to avoid the choking. But when we are firing the biomass, then mill inlet temperature also becomes very important. So control of mill temperature shifted from the outlet temperature to the inlet temperature. Also, PA head of pressure, primary air head pressure, the air which is carrying this biomass and fuel mixture to the furnace. This pressure is now also maintained slightly higher side, so that there is no residual in the pulverizer. Also, for the safer side, suppose if there is any fault in the control and instrumentation area, suppose there is fault in any hot air gate, hot air damper, cold air gate, cold air damper, the gates from which the air is coming, hot air is coming, then the temperature can shoot up. If temperature shoots up, then there are chances of fire. So to avoid this condition, additional protection has also been provided at 195 degrees centigrade. Suppose if temperature reaches 195 degrees centigrade, then automatically hot air gate will close. And as soon as the hot air gate closes, the hot air reduces and the temperature will start coming down. So these were some modifications from the control area sides. Apart from that, we did modification from the in mill inerting system also. Mill inerting system is basically the steam line which is provided near the pulverizer for in case of any emergency, in case of any fire in the pulverizer, this steam line will be used to quench the fire in the pulverizer. So in all the power plants, the mill inerting line is already available, but normally it is in the manual. Manual means whenever there is a fire, then we need to go to the site and open the manual steam valves. As the chances of fire in the biomass co-firing is very high because due to the high volatile content. So we provided additional motorized valve in the downstream of the manual valve. So that mimic of the motorized control valve will be available to the control room for the operator. So if there is any fire, then the control room operator can take action and he can open that motorized inerting valve from the control room itself. Also, there can be localized firing in the pipe also, all 4 pipes which are going to the furnace from the pulverizer. There can be localized fire also, and we cannot depute the local operator all the time at the near the pipes. So for that purpose, we provided the additional temperature points in the PF pipe also. These points will be available in the control room, and related to these temperatures, the alarms will be available in the control room. Suppose if any abnormality in any pipe temperature is there, then alarm will enunciate in the control room, and operator can take action accordingly that whether mill should be stopped, or mill should be kept in service. Also, one more modification was done that we provided an orifice in the mill inerting line also to control the steam pressure. Apart from that, in the feeder area, from where the controlled feeding of the biomass and fuel mixture is done in the pulverizer, in the feeder area, we provided the cleaning arrangement of the view glass because so that local operator can see in the feeder running condition whether biomass is coming or not. Also, illumination inside the feeder was also provided for this biomass co-firing. So these are the normal mill parameters which we maintain during the biomass co-firing. Mill outlet temperature is maintained as around 60 to 65 degrees centigrade. We do not go below 60 degrees centigrade to avoid choking. Mill inlet temperature, as I already explained, maintained around 180 to 185 degrees centigrade. P head pressure is normally maintained more than 800 mm water column. In the initial days of biomass co-firing, we used to maintain it more than 800 mm water column, but nowadays we maintain it around as good as 100% coal firing. Purging of the mill is the normal process. Whenever we start the mill and stop the mill, we do the purging. But in case of biomass co-firing, it becomes mandatory so that there is no residual in the mill. Also, continuous monitoring of the pulverizer, like the mill current. Mill current normally increases because of the moist fuel. Mill inlet temperature, mill outlet temperature, mill DP, all these parameters should be monitored. These monitoring becomes very important if we are firing the biomass in any mill for the first time. Also, the role of local operator is very important whenever we are firing the biomass in the mill, because mill reject system should be kept in under continuous observation for the cleaning of the mill reject. Also, for the first time biomass co-firing, operator should be deployed at the local for in case of any fire so that he can inform the control room. And in the initial days of biomass co-firing, we used to deploy the fire tender near the mill so that if there is any fire, then we can immediately quench the fire. But in our experience of the last 5 years, there has been no fire incidents of during biomass co-firing. Also, all other parameters like flue gas temperature in superator zones, clinkering and slagging tendency from the S panels, all these parameters should also be monitored. Now coming to the performance analysis, when we are firing the biomass, there is in this slide we are talking about the 210 megawatt units. For the other units, these parameters will change. These are not fixed parameters. So there is an increase in the exit flue gas temperature also when we are firing the biomass. So why this increase is there? Because of the procedure we are following for the biomass co-firing. Because we are reducing the mill inlet temperature. So when we are reducing the mill inlet temperature, then the air going to the air preheater, which heats the air, it will be low. So ultimately there is underutilization of the air preheater. So exit flue gas temperature normally increases when we are firing the biomass. Due to this, slight decrease in efficiency, in boiler efficiency is also there. Also, increase in mill power is also there because when we are firing the biomass, normally slight increase in current is also there, mill current, because due to the moist fuel. Also, we need to run the extra conveyor for carrying this biomass to the bunker. So for that slight increase in APC is also there when we are firing the biomass. Also, there is a decrease of unburned carbon in the fly ash because due to the high volatile content. This is the biomass intimation slip. As soon as the coal handling department, fuel handling department feeds the biomass in any bunker, so he provides this slip to the operation department, which is running the mill. So from this, in this slip, all the parameters related to biomass is available, like how much quantity of biomass has been fed in that bunker, from which height to which height the biomass has been fed, and what is the percentage of biomass co-firing is in that bunker. From this sheet, the operation person which is running the mill, he gets the approximate idea that at this feed rate, how much time it will take for the biomass to come into the feeder. And he can deploy the local operator for that purpose, and accordingly, he can take this biomass mode in service. Because we cannot keep the mill in the biomass mode continuously. Because if we are keeping the mill in the biomass mode continuously, then we are losing the boiler efficiency. So we cannot keep this. So whenever the biomass starts coming, we keep the mill in the biomass mode, and the mill is kept in service. So what is the procedure for changing? So in the brief, I will explain the procedure for changing the biomass mode. So as you can see, this is the inlet temperature and outlet temperature of the mill. So when we are running the mill in the 100% coal mode, then biomass mode will be in off condition. And as soon as the local operator informs in the control room that the biomass has started coming, then we will keep these dampers, hot air and cold air damper, which are controlling the mill temperature, we'll keep in the manual, and we will reduce the temperatures manually. And as soon as the temperature reaches mill inlet temperature, pulverizer inlet temperature reaches to 180 degrees centigrade, we will keep this biomass mode on, and after that dampers are put in auto. As soon as we are putting this biomass mode on, the control philosophy of pulverizer shifted to the mill inlet temperature, and we can keep the temperature set point in the according as per our convenience. And similarly, vice versa is the procedure for the taking any mill out of the biomass mode. We will open these dampers in manual, and after that we will increase the mill inlet temperature, and after that we will keep this biomass mode off, and after that we will put these dampers in auto. This is the procedure. So what happens if there is a fire in any mill which is running by using biomass? So there is a standard operating procedure in all the thermal power plants for the case of fire in the pulverizer. The same procedure is followed in Dadri also, but there is same procedure is for the biomass co-firing also. If there is fire in the mill in the 100% coal, and same procedure for the 100 biomass co-firing also, the same procedure is same. But only difference is there that we have the control of the mill inerting motorized valve also in the control room. So we can open this also whenever there is a chance of firing. But rest of the procedure, like the quenching the fire for the depraving the mill from the air side and the fuel side, this procedure is same. These are the photos of the biomass receipts and unloading at the sites. These are the photos of the biomass storage. Initially, we did not have the covered storage facility for the biomass storage, and biomass is very hygroscopic in nature. So when the biomass is kept in the open condition, then it absorbs some moisture. So it is a normal procedure in our power plant that whenever biomass is received at the site, we feed it to the bunker instantly so that their moisture content will not increase. So in the later phases, we developed the covered shed facility for the biomass storage and the separate silage for the biomass in the commissioning phase, so that whenever the biomass will be received, the biomass will be sent to the biomass silage. One more achievement for NTPC Dadri which I wanted to share was the torrefied sludge firing. So we received approximately 30 metric ton of torrefied sludge from the Delhi Jal Board on the 15 April 2022. So this torrefied sludge was having quite low GCV. So we selected unit 4 for this torrefied sludge firing, and our biomass firing operation was very successful, and there was no abnormality was observed. Finally, coming to the benefits of the biomass co-firing, in the Dadri we have burned up to now 21,000 ton of biomass. So we have, because biomass is a renewable energy, so we have saved up to now 21,000 of fossil fuels. So conservation of fossil fuel is there. So from by 1 ton of coal, approximately 1.4 ton of CO2 generates. So by saving this 21,000 ton of fossil fuel, we have reduced the greenhouse gas emission by 27,000 ton approximately. Also, as the ash content in biomass is lower, so the ash transportation cost we will save money in the ash transportation cost also. So we have calculated accordingly. Also, as the sulfur content in biomass is low, so SOx emission control cost will also be reduced. All these calculations are done based on assumption that we are running a unit at the 10% blending, 210 megawatt continuously at 100% PLF for the 5-month period. Also, there are benefits to the farmers also. The farmers' benefit is around 1,500 to 2,000 rupees per acre. So there will be also development of the entrepreneurs' skills also, and opportunity for new businesses also be developed. So with this, I would like to end my presentation. We are open for any questions from the audience side, any stakeholders. Yes, because in the biomass sampling, apart from size, we check for the moisture also. Because if the moisture content in the biomass is high, then there is a problem from the milling side. We cannot grind the moist fuel. If there is very high moist fuel, then the mill current will increase, and we cannot go very high moist fuel. So also the feed rate of the mill. Suppose we are reducing the moisture by increasing the inlet temperature. Suppose outlet temperature is maintained, and we are reducing the feed rate, then increase in APC. So we have maintained an optimum level of 14%. That below 40, after 14%, we will not accept the sample. Sir, all the studies has been carried out by Netra. So for the 10% co-firing, there is no effect has been observed. No such issues. Because if we are going beyond to 10%, there will be issues for the boiler and the ESP side, because the alkali and chlorine content increases. And as soon as alkali and chlorine content increases, the corrosion, slagging, clinkering, all these tendencies develop. So for 10%, it is the safer side. If we want to go beyond 10%, then we have to go towards the torrefied solution. Because in the torrefied, all these parameters are lower. Chlorine content, alkali content are lower. So we can go beyond to 10%. But up to now, we are receiving only non-torrefied coal. So about non-torrefied coal, we have restricted ourselves to the 10%. No, Netra is in the studying for going the higher percentage for the torrefied. But we are not receiving any torrefied. Mostly we are receiving the non-torrefied.
So as you told, it is non-torrefied. So if I want to understand, what is the percentage of rejections by percentage per day in your Dadri plant? As because you are operating for last 4 or 5 years, so it is the testing we are doing in-house. It is not from the manufacturing state. So what is the percentage in ballpark, if I want to understand, of rejection per day?
The percentage of rejection are very low. We are the moisture content that we are receiving in biomass samples is more or less 5%. Most of the samples we are receiving are being accepted.
So apart from moisture side, what is different in the ash percentage? Because you cannot maintain the same sieve size for the biomass sampling what we are using for coal. So it creates difference in the ash, and GCV is a calculated value. So if we are doing with the same pattern, the GCV will be lesser.
We incentivize the vendors for providing the higher GCV biomass. For that purpose, we have the procedure for the pricing according to the GCV. So GCV is not fixed. If after receiving the sample is sent for the GCV checking. If the GCV is low, then payment according to the GCV.
No. My question is something different. I just want to ask how the sampling process for the ash content is different from the coal part, because it cannot be same. If you are using the same process for the biomass sampling, you will have the less GCV at the final output, because ash percentage will be the higher. Whatever the sieve size you will select, the heavy particle will come down as the ash percentage will, because heavy the biomass content the ground material also. So when you use the same sieve size, the heavy particle will come down, so ash percentage will be increased, and the ash percentage will increase, your calculated value of GCV will be came down. So actually, that's the basic problem we are facing.
Actually, 3 different tests are done. The moisture we are calculating through the equipment that we have already shown in the slide. The sizing is done through the sieves that you are telling, and GCV is calculated after we have fed the biomass sample. These 3 tests are altogether different.
You must be receiving different kinds of pellets of different biomass. So is there any criteria or any kind of notifications you have identified that this biomass of this percentage can be used as the input? Or the percentage of rejections for a different type of biomass as a pellet? Any philosophy you have defined in that? So that it will be easy for the suppliers to feed you in terms of the kind of biomass pellets they want to supply.
Size criteria is already provided whenever the PO is placed for the any biomass. We accept the maximum size is 25 mm for the any biomass. We do not go briquette because briquette creates.
No, I'm talking about the type of biomass types, like rices, or the different types.
Different raw materials are accepted like paddy, straw, all mustard. Very different kind of biomass has already been received.
All the testings you are doing in-house in Dadri itself.
Yes.
Okay,
we are restricting only from the size, moisture, and GCB. And apart from that, we are not restricting from the biomass side. Whether it is wood residue, whether it is agriculture residue, it is not an issue.
And the feed is adequate enough to run the operation smoothly.
Yes.
Thank you.
Size is very important. Size is very important for the running any mill in the thermal power plant because beyond 25 mm size, that creates choking in the mill, currents problem, various issues came. So size becomes very important, and accordingly GCB and moistures are already explained.
Thank you.
Sir, in normal operation, we load the mill up to 90%. What is the maximum you achieved in terms of, in case of the pellet firing?
Sir, normally the mill inlet temperature, when we are running the mill feeding to the 90%, around 300. So mill outlet temperature is maintained accordingly at the 90% feeding. But when we are reducing the mill inlet temperature, so mill outlet temperature we also reduce, we are keeping the same feeding. So we have to reduce the feed rate also. So normally whenever, and also it also depends on the content of the moisture also. So ultimately we have to reduce the feeding. Suppose if mill is running at the 100% coal at the 50 ton per hour, so it may be possible, then whenever the 10% biomass, we are taking the biomass mode in service, then the feed rate has to be reduced from the 50 ton per hour to 30 ton per hour. Or sometimes we have to take the extra mill also in service to maintain the overall feed rate.
So that's why my question is that at present we are doing the trial in one mill only. But as per the government notification, we have to fire 5% the total coal. It is practically possible to fire 5% in total coal and achieve the 100% PLF.
Sir, we have fired this in the NTPC Dadri Unit 4. All 4 running mills at the 10% biomass we have fired. There was no issue. From the flame side also, in the flame because volatile content is higher, so flame intensity improves. Whenever we are firing the biomass, the flame intensity improves. And also, we are running the mill at the lower side, we have to take the extra mill in service. If we are firing the biomass in all the mills, then we have to take the extra mill. But we are maintaining, we are maintaining at full load.
Maybe you fire, in that case, you maybe fire the higher GCB coal.
That might be the case. Yes. I do not have the data.
I think, as per my experience, at design coal GCB, it is not possible to achieve the 100% load.
Sir, I have one question here. This side. Sir, you told that from 2017 onwards you are firing. So what is the maximum continuous time you have fired along with biomass, and what percentage?
Sir, initially we used to receive the biomass continuously. From the last 6 months we are not receiving biomass, but in initial days we used to receive the biomass continuously. So it was our normal practice that because in Dadri we have 6 units, all 6 units have been prepared for the biomass co-firing. So normally in our practice, regular practice, that if the quantity of biomass is low, we normally used to run only 1 mill in biomass mode. Only in the one bunker we used to feed the biomass because or continuous it was in service for the around 3 days, 4 days. For continuous in biomass mode, it was in service.
Sir, my question is, suppose 210 megawatt you are running at full load, then are you firing 10% of the total coal continuously, or it is just in one mill you are firing 10% biomass?
In one mill, because we are not receiving that much quantity.
That means if we go a rough calculation that 4 mills are in service and each mill is equally loaded, you are firing 2.5% of the total coal.
For the testing purposes, we have fired the 10% biomass in all the running mill. But right now we are not receiving that much biomass that we can run all the mills in the biomass mode. So that much quantity has not been received.
In terms of total coal consumption in your 210 megawatt plant, what is the maximum percentage of biomass you have fired continuously and for how long?
in only one mill, continuous 10%, around 7 to 10 days.
That means only 2.5% of the total coal, if all mills are loaded equally.
Yes. Yes.
Continuously for 7 days.
Yes.
You are not facing any issues with respect to cold air dampers? Are they not getting saturated? Because you told you are maintaining mill outlet.
No issue in cold air damper. Temperature is maintained. Accordingly, outlet temperature, we reduce the feed rate. Suppose outlet temperature is going lower than 60 degree, we reduce the feed rate. So we are not facing any issue from this.
So you are maintaining the cold air damper position.
There is margin. There is sufficient margin cold air damper also when we are firing the biomass.
Okay. Thank you.
I have one.
So what is the GCV for paddy biomass? GCV
or biomass?
Paddy biomass specific.
Paddy exact data is not available with me, but it changes with every sample. Even if for the paddy, the GCV value changes. It is not fixed around.
Not fixed. Any averages?
I will get.
Average GCV of the biomass that we are receiving at Dadri is around 3,800.
You are receiving paddy biomass over there or some other
all
crop?
Kind of biomass. Because we are checking only for the moisture content, sizing and GCV.
Okay. I will collect this data and I will get back to you from our concerned department.
And what are the specific sizes of pellets? Any specific size which is convenient?
Around 3 mm, 5 mm, 10 mm size we have received. 3 mm size is normally normal.
3 mm. Okay. Thank you.
Good afternoon, sir. My name is Sanjeev Kumar Panda. I'm from Jindal Stainless. I would like to understand this mode of control, as you said, for the biomass operation and non-biomass operation. So that was developed by NTPC in-house, or you have?
It was developed by NTPC in-house. So based on our proximate analysis, we found out that we cannot go beyond 200. So for the safer side, we maintain around 180 to 185. That in any case, we do not go beyond 200. It was all the parameters, all the control was developed in-house.
So what were the changes that were required, sir? As you said, the damper controls and all this. So with the existing, whatever we have, because the controls are definitely there in the DCS right now also. So with those existing, we could develop in-house and convert it to biocontrol mode. And obviously there is the non-biomass control mode. So that was not that challenging, or was there something which you would like to share with us?
Sir, beauty of 10% biomass co-firing is that we do not have to change much. We only have to work from the control and instrumentation area side. We need to provide this mode, biomass mode. All the inlet temperature is already available in all our power plant. Outlet temperature is already available in power plant. If possible, provide additional temperature in the local pipes also. Because if we are firing for the biomass first time, then there can be localized fire also. So we provide additional points was also provided in the local pipes also. But apart from that, not much modifications were done. Like small modifications like the motorized inerting valve was provided. This is very small modification from the thermal power plant point of view. So no big modification.
So that was also integrated to the biomass control mode, sir? The inert.
Initially, before biomass co-firing, we had only the manual control. But after before biomass co-firing, we provided additional motorized inerting valve also.
That
but
was
it is helping us
sir,
in the imported coal also, because in the imported coal also the BM content is higher. So it is helping us in long run.
So that was integrated to the biomass control mode operation?
No, it is not integrated in the biomass control mode. Biomass control mode only changes the mill temperature philosophy from the outlet temperature to inlet temperature.
But that was also done in parallel?
Mill inerting motorized control valve, work of mill inerting motorized valve is to quench the fire only. In case of emergency.
Yeah, that will work
until now,
temperature.
In the last 5 years, we have not used the mill inerting motorized valve. We have commissioned, but we have not used because there is no case of fire till now.
Sir, one more question, just a very basic question. Generally we talk about non-torrefied and torrefied pellets. I would like to understand whether NTPC has the experience of firing both the types and in fact also briquettes. NTPC has NTPC fired all the three, sir?
Sir, NTPC has not fired briquette because as already explained by me that in briquettes it creates problem in the mill. There are chances of choking in the mill. Also mill current will shoot up. So we do not fire briquettes, we fire only pellet form.
But as you are saying, sir, you have tried to do that, but it was not a good experience.
During testing phase by Netra,
yes, sir.
We concluded that it cannot be fired because biomass co-firing is already developed in other countries also. So based on that experience also and based on tested by Netra, Also, if we are talking about the torrefied, so we incentivize torrefied because it acts like a coal. So we will have much better control if we have the torrefied biomass. But
Cost
mostly
will
we
be
receive
higher.
the non-torrefied.
So cost is the constraint in
The torrefied cost
using
is higher. Cost is provided higher by the NTPC if the torrefied coal is there, because GCV is also higher and the cost is also higher. Recently, I think 8 to 9 rupees. 8 to 9 rupees for torrefied coal was.
Okay, sir. If I ask you, what will be the preferable type of biomass to be fired, whether it is torrefied pellets, whether it is torrefied or non-torrefied, are you suggesting it should be torrefied?
It should be torrefied. We would prefer torrefied, but in the non-torrefied, until now we have fired 21,000 ton of non-torrefied biomass. So we have faced no issue in the non-torrefied also, but we would prefer torrefied.
Thank you, sir. Thanks.
Hi.
Hello, sir.
My name is Ron.
Hello. My name is Sridhar. I'm from National Institute of Bioenergy. See, I have one fundamental question to you and also earlier colleague from Netra. You agree that biomass has oxygen in that, right? Oxygen content, right? So did you optimize anything on the air supply when you operate your boiler?
Sir, I did not understand the questions.
See, biomass has oxygen in this. So you're replacing 10% of your coal with biomass. So there's excess air available already. So did you optimize on the air supply and then you'd fine tune on the efficiency part?
Optimize the mill.
Air supply for the boiler operation.
No, optimize means quantity of air.
Yes.
Sir, we optimize the quantity of air. Suppose based on the feeding, automatically there is a set point for the air set point also. Suppose we are firing the 30 ton, so set point may be 75. We are feeding the 50 ton, then set point may be 85. So or the set point which is required is maintained according to that. We do not fire excess air. We do not give excess air to the mill. So it's already in optimized condition.
So did you measure the excess air in the exhaust, both with coal and with co-firing?
So in the exhaust, because normally we are taking the extra mill in service, so excess air, because excess primary air is going, so excess oxygen will be, excess air has to be provided if we are running the extra mill due to that.
So did you measure the excess air factor in the exhaust?
Right now I don't have the data, but these data are available with our energy efficiency department of the testing phase. But normally the excess oxygen at the exit side, economizer outlet oxygen is set point is fixed normally. It is kept in auto in NTPC. So suppose it is maintained at the full load around 3.5. 3.5% oxygen is maintained at the economizer outlet. So accordingly, that excess air is being provided or reduced. But excess oxygen point is fixed.
But if you have not done, my guess is that if you can fine tune that, your efficiency also will be same. You'll not lose on the efficiency.
Efficiency side, we are losing little bit.
Yeah, that's what I'm telling. So if you optimize on that, it may be
sir.
Efficiency could be the same, I would say. Thank you.
Okay, sir. Thank you, sir.
Hi, my name is Roshan. I'm an entrepreneur and at Ramanujan Labs and a researcher at Princeton University. I had two small questions, one on the engineering and one on the governance. So you're taking raw crop residue, right, and you're aggregating it into some kind of bales. Then you're further densifying it, making it to something like a briquette or a pellet. But when you take it to the plant, you're still checking for a host of metrics, and then you're pulverizing it again. So you're undensifying it again. Why doesn't NTPC think about procuring maybe bales and then using loose straw, just like what you do with coal? Why are we going through a densify the thing and then undensify it at the plant? Why not just buy bales and then burn that with the coal itself? And the second question is, you said, I think for 6 months you haven't co-fired because you haven't got the supply at the site. But I feel like there's at least a few friends of mine who run factories, they have government mandates to co-fire biomass. Now, if the public sector and a large PSU can't figure out the supply chain, what is the expectation on how the private sector or smaller people who don't have as big balance sheets will be able to figure out that whole supply chain and the costing as well? Thank you.
Good question.
Hello. I need to ask one question. Is there any storing norms for the biomass like related to weather and temperature also?
Pardon?
Is there any storing norms in the warehouse related to weather and temperature?
Actually, biomass pellets are hygroscopic nature. So during rains, it catches moisture very soon. So we generally don't get biomass during our rainy seasons. And storage capacity, there is no temperature norms. We have the storage facility and we store it over there, and we feed it on the daily basis. The day we get it, we feed it on the same day, so that it do not get the moisture. And your question.
Hello, sir.
Sir, please respond his first, please.
Sir,
his question, yes, please.
I'm giving answer to this question. Sir, actually, the thing is that biomass, the raw material for the biomass is not available throughout the year. So this is the problem that many people are facing. And NTPC right now is not in the business of collecting this. Maybe in coming future, they may go into this, some kind of subsidy or so.
Sir, the question is different, sir.
The
question is, like, as you mentioned, that you are not procuring any the biomass during last 6 months. So he would like to know why you are not. On the contrary, we are having many plants. Those are not able to sell the product. So where is the gap?
Sir, in the Dadri, if we calculate the biomass demand based on our 40% PLF also at the 5% co-firing, then we require around 590 ton per day of the biomass. So already the PO has been placed for the 280 ton per day for the 4 years by the vendors. Also around 530 ton per day PO has been in the letter of award stages. But the PO has been placed, but still the vendors are not able to provide this. Maybe.
Sorry to differ with you, sir. You have the bucket filling system. Your tending system is the bucket filling system. So when others are not providing, give the chance to the L4, L6, L8. Why you are sticking yourself up to L1 and L2 only?
Separate PO has also been placed, no?
Sir, I know many. Yeah, please.
Sir, actually, three POs has been placed for non-tarified, a long-term PO, and for last year for tarified pellets, 7 POs has been placed. They are in the LOI stage.
Sir, my question is, like, as you are saying that since last 6 months, you are not able to get biomass. I am saying the situation is different. There is lot of pellets are available. Rather, last time also we had gone to ministry and we had represented that our plants are idle. NTPC is not buying. So NTPC should now come forward and have a meeting, table meeting. Why we are able to provide you the biomass and you are saying that you are not having since last 6 months. So there's see, we are spending a lot of time and money on these kind of conferences. But why we are not discussing this thing one-to-one with the manufacturer?
Sir, recently, mainly the biomass was not available because the vendor was getting the better prices at the local area also. That was the main reason, because initially...
Sir, reason is the price. You are only confining yourself with L1 and L2. And L1, L2 people are not serious. So those are producing biomass, serious manufacturers, they are not getting the opportunity. So I request you to kindly have such kind of a meeting.
Can I respond to that question?
Yes, please, sir.
Yeah. As far as Dadri is concerned, based on the mandate given by the government, the quantity that is required, POs have been placed for quantities more than that. Second, because the capacities in the manufacturing, pellet manufacturing are not as much as is required. Demand, supply side is much smaller than demand. So what we have done is, in the terms and conditions of the contract, we have given 9 months lead time to the vendors to start supply. So these orders are placed sometime in July or August. So that 9 months period will be ending sometime in April. So that much time anyways we have to give to the vendors. Second is, those who are from the pellet manufacturing side, they know there has been a lot of volatility in the on the raw material side. So some of the assumptions that were taken by the vendors at that point in time, perhaps that are no more applicable. So it's making somewhat difficult for them to meet the price that they had quoted. So we are allowing them slightly more time so that they can like in the area around Gadawara, Khargon, the supplies had stopped because of raw material price. Now it has again started. So perhaps it's as the market matures, there will be some stability on the raw material side, and the supplies will, the new vendors will be able to start the supply. So that period ends sometime in April or May. We are in continuous touch with them, and we expect the supplies to start. Second, if that doesn't happen, now we are again going to come up with short-term tenders for Dadri, wherein, if there are some other vendors who are in a position to supply, they will be, given opportunity. So we have to go with a mix of, long-term tenders and short-term tenders, because, the capacities are not available on the pellet side. Demand is much higher. So we have to, it's a learning process for the suppliers as well as for us. So we have long-term tenders in place, and we will be coming up with the short-term tenders, not only for Dadri, for other stations also. Moda has already started processing for a short-term tender. So that's how we propose to proceed.
Sir, fair enough. My humble submission is, when you initiated this tender, you have mentioned this is bucket filling tender process. So why don't you give the opportunity to L6, L7, L8?
I'll respond to that. That bucket filling tender was the first one, which was the 9-month tender. This particular tender, we have been able to, get vendors at L1 price. That's why the requirement, like I said, for Dadri, Jhajjar, we have been able to meet, we have got enough responses to meet our requirement. So those LOIs are in place, only that 9-month period is still going on, and we expect, at least many of those vendors to start supply. And many of you may be aware, for Jhajjar, we had also gone with the short-term tenders against which we have got the supplies. Again, now we are processing around 150 tons per day orders for short-term. So that's how we are proceeding, a mix of long-term as well as short-term.
Fine, thank you.
What Mr. Roshan asked, I am just further simplifying it. He meant to say, first you are densifying the material, then again you are undensifying it. So why not to go for direct firing?
I'll respond to that as well.
Yeah, just a minute, let me complete, please. So I mean to say, as you have got power plant which is using raw biomass or loose biomass in Punjab, in Rajasthan, so instead of complicating the system, existing NTPC system, NTPC should go for a power plant based on loose firing of biomass.
I'll respond to that.
This will also reduce the cost of energy, because you are spending considerable amount on densifying, again pulverizing and transportation.
Yeah. Can I?
Yes, yes.
Actually, our power stations have bowl mills. Now they cannot be, milling a fibrous material. So basically that, densifying and undensifying is basically reducing the particle size. Let me finish. That's one. Second is, this raw material is dispersed. It's not, it doesn't have high energy density like coal, wherein you can transport from one place. So transporting from long distances, even in baled form, the bulk density is around 200 kg per meter cube. And when you are actually, milling it using hammer mills and then densifying, the bulk density goes up to 650 kg per meter cube. So that reduces the transportation distance, cost of transportation. Second is, with this we can use the existing power plants for firing the biomass. Whereas, if you want to use it in a raw form, then you require specific power plants which can burn that kind of fuel. The pulverized fuel boilers cannot do that.
See, in Punjab, you have got successfully running plants.
I think we can discuss after the meeting. I think we will have to proceed with the session.
No, we are not looking at the simplest part of utilizing the biomass which is available in abundance. We are just trying to look for a complicated solution.
No, it is not. Actually, if we are co-firing, then a lot of capital investment that goes into setting up the power plants, we are saving on that. If you are setting up a new power plant, a lot of capital investment goes in, their heat rate is much higher, they have very low efficiency. So we are saving a lot by co-firing in the existing assets. Thank you.
Sir, till date, how much percentage you have achieved in any of your plant in monthly basis?
How
much blending percentage, sir?
Blending percentage maximum 10%.
No, on monthly basis.
Monthly basis around, exact data is not available, but around 5 to 6% we have achieved.
And my question is from Nitra also regarding Whether we have done any study regarding, since we are taking some residue from field and transporting it through trucks to manufacturing plant, there again we are using energy on that, then again transporting. So it is long cycle. How much energy input we are giving to manufacturing of fertilizer?
So actually I would, if there is any question from the operational side or handling sides, then it would be better, because it is not my expertise from that point of view.
What is your expected price for this pelletized biomass?
Expected price of pelletization?
No, pelletized biomass. At what price band you are looking for the biomass?
Recent PO was placed for the 6 rupees, 7 rupees, for the torrefied 8 rupees stuck also. For non-torrefied 6 to 7
I'm
rupees.
afraid you will
and for
get
the
any
torrefied,
biomass on this price.
And for the
At
torrefied,
least this pelletized.
around 8 rupees.
That's why maybe I am seeing a failure of this complete scheme. If you are seeing this as 6 rupees with the and comparing with the calorific value along with it, then it is not possible to make a success of this.
Sir, this is the reason, rather than spending lot of time and money on these kind of conferences, if we really want to have a success of this is the right thing.
And
one
more
side,
thing, one more thing.
4,000 rupees is the cost of the biomass
May I finish?
declared by the government.
Maybe your queries will be further more explained by the speakers which are coming into the next sessions also, because our presentation is mainly focused on the operational side and the handling side also, because I cannot answer all these kinds of questions.
Yeah, we know that. You are a technical
because
person.
I am a technical person from the power plant, so I am not right person to answer your question.
Sir, 4,000 is the biomass raw material cost, and you are expecting 6,000 rupees. One side. Second side, other side is you are not offering this to L1, L6, L8, that kind of bucket filling procedure. That's why you are not getting, since last 6 months, biomass. This is the reason.
Gentlemen, I think this include the GST, transportation, loading, unloading, and everything.
Yes.
So just let me respond. So
we need to discuss on this, I think, in debate.
One-to-one, sir, rather than having
I
this
think
technical.
we appreciate what kind of success you have made for the co-firing
now.
there. It is really appreciated.
Yes.
But now we have to come to the commercial world to make it a success.
Purpose of this conference is also that
Yeah.
one-to-one talk can also be there, so that all your queries and all the problems can be solved.
So let me say something. So all these questions are very valid, and this will be very critical for success of the entire thing. But then this presentation is only for how the biomass can be co-fired, how the percentage can be increased. So let us restrict only to the topic of the presentation. All the questions will be taken subsequently.
हेलो
हेलो हेलो
आप लोग का ये बायोमास लेने का जो निर्णय है
हेलो।
इसका पहले तो स्वागत है, बहुत अच्छा निर्णय है, लेकिन इसको सुनिश्चित कैसे होगा कि बायोमास आपका डिपार्टमेंट या जो थर्मल पावर प्लांट वाले हैं ये लोग लेंगे? ये लोग वहाँ पे बहाना करते हैं, जैसे मैंने प्लांट लगाया छत्तीसगढ़ में, हाँ, तो ये लोग कोई रिस्पॉन्स नहीं देते, हैंडलिंग नहीं है हमारा, ये नहीं है। रेट तो एक अलग बात हो गई साहब, पहले तो आप इनको बाउंड कीजिए कि माल लें, जैसे हमने इन्वेस्टमेंट कर दिया, अब ये बोल रहे हैं हमारा वो नहीं है, हैंडलिंग प्लांट नहीं है, हमने लेटर लिखा है, हम उसको रखेंगे कहाँ, हमारा साइज डिसाइड नहीं है, क्या लेना है, वो कुल मिलाकर बहाना है। और इनका टारगेट क्या है? कुल मिलाकर कॉमर्शियल ट्रीटमेंट। ये बोलते हैं इनको मुफ्त का कोयला मिल रहा है सब्सिडी का, ये बायोफ्यूल क्यों यूज़ करेंगे? हम अपनी अगली जनरेशन को क्या देंगे? अब पूरा कोयला खोद के ये पूरा इन्वायरमेंट को खराब कर दे रहे हैं, और बायो प्रोडक्ट लेने के लिए इनका नाना प्रकार का बहाना है साहब, चाहे वो रेट को लेकर हो चाहे वो हो। तो ये डिसाइड हो जाए तो उसमें मैन्युफैक्चर कैसे आगे आएगा जब उसको लेने का ही तय नहीं है। जैसे हमारे यहाँ बालकों का है, वो बैठे हैं भाई साहब बालकों वाले, कहाँ गायब हो गए क्या? उनको बोलिए कि जवाब दें मेरी बात का। हाँ, इनने जैसे आपने कंपलसरी किया है 5 से 10% तक कि हमको लेना अनिवार्य है, ये लोग सर क्या? हेलो हेलो, अब ये लोग बोलते हैं कि हमने टेंडर कर दिया है, अब अगले साल टेंडर करेंगे। एक्चुअली क्या है
कि जैसे मान लीजिए जितना कैपेसिटी का इन्हें टेंडर फ्लोट किया है और जो टेंडर पार्टिसिपेट किया है उसको इनने पूरा ऑर्डर प्लेस कर दिया, और अदर जो दूसरे मैन्युफैक्चरर हैं उनको कोई वो नहीं, L1 L2 L1 का बहाना करके, और उससे पूरा माल लेना शो कर रहे हैं ये, जबकि उसकी कैपेसिटी ही नहीं है देने की। प्रोडक्शन सर्टिफिकेट, प्रोडक्शन कैपेसिटी ही नहीं है, उसका सर्टिफिकेट भी नहीं स्टेट गवर्नमेंट का, लेकिन उसको ये लोग शो कर दे रहे हैं कि हम माल पूरा परचेज कर दे रहे हैं, गवर्नमेंट का नाम पूरा कर दे रहे हैं।
So if there are no
वो इसलिए कर रहे हैं
so
क्योंकि उनको सब्सिडी का कोयला मिल रहा है इनको।
just let me
इनको
intervene.
इन्वायरमेंट से इससे कोई लेना देना नहीं इनको।
If there are no
इनको
questions
सिर्फ
on the
कमर्शियल बेनिफिट चाहिए कि इनका फायदा पहुंचा दिए कंपनी को, हमारा प्रमोशन हो गया, हम एमडी हो गए, सीएमडी हो गए। तो सबसे पहले तो उसमें सुनिश्चित हो कि लेने के लिए आप बाउंड कीजिए इनको।
So if there are no questions on the subject, let us close this presentation.
और इसमें सर
Yes.
मेरा एक और कहना है, सप्लाई में एक पीवीसी क्लॉज रखा जाए, है ना, पीवीसी क्लॉज रखा जाए, यदि रेट बढ़ता है एक बायोफ्यूल का।
ये
सॉरी सर, यहाँ पे मैं इंटरप्ट करना चाहूँगी आप सभी को। एक बार जोरदार तालियों के साथ हम अपने प्रस्तुतिकर्ताओं को धन्यवाद करते हैं, और अब प्रश्नों उत्तर का सेशन यहीं रोकना चाहेंगे। आप सभी को बताना चाहेंगे माननीय मंत्री कुछ लेट आएंगे, आप सभी से निवेदन है कृपया आप अपने स्थान पर ही बैठे रहें। Ladies and gentlemen, the Honorable Minister is on his way. We would request everyone to kindly remain seated. Thank you. Ladies and gentlemen, we request everyone to kindly remain seated. आप सभी से निवेदन है, कृपया अपने स्थान पर बैठे रहें। माननीय मंत्री महोदय कुछ ही समय में हमारे बीच उपस्थित होंगे। उनके आते ही हम उद्घाटन सत्र की शुरुआत करेंगे।